Welcome back to Forbidden Knowledge News. I'm your host, Chris Matthew. Tonight my guest is Mark Fiorentino. Before I bring him on, just a couple of announcements. First, you can always get all new regular episodes free on Rokfin, Odysee, and all podcast platforms. Click that link and check us out on Rokfin. This is where you get all our premium content, regular shows, and all the amazing content from every creator that's there with us on Rokfin. Check out all the new amazing podcasts from the Forbidden Knowledge Network, such as Inception, Raised by Giants, Day Zero, Dawson Time, and of course, Beyond Classified and Forbidden Knowledge News. You can now get them all in one place. Our website, forbiddenknowledge.news, that is forbiddenknowledge.news, or click that link in the description. Finally, guys, you hear me talk about it all the time. If you're reaching that stage in life where you're getting a few of those gray hairs, you might have a little less energy, check out C60 Purple Power. It may be the most powerful antioxidant known to man. It's helped me with inflammation, energy, sleep, well-being, and the list goes on and on. You can get C60 for your pets, and your pets can feel awesome too. Check out more. Click the link in the description. See what they have. You can get 10% off your order plus free shipping. Now tonight I want to welcome back to the show Mark Fiorentino. He has been obsessed with Einstein's unified field theory ever since hearing about it when he was 10. He worked for many years in the high-tech industry, including for IBM, and he is the author of Master of Reality. Mark, welcome back. How are you doing today?
Fine, thank you. It's good to be back.
Yeah, it's great to have you back. Been looking forward to it. Last time you were on, we barely scratched the surface and discussed a bit about your work and research with Einstein's unified field theory and how it could be used for basically anything from traveling through space, renewable energy, and plenty of future technologies. And I want to go even deeper tonight, as well as talk about any new work or research you're involved with. Now, it's been a while since you've been on, like we were talking about before. Let's remind the audience how you got involved with this research and what ultimately led you down this path.
Okay. Well, many things. At least two different nudges got me into this. One, very early on, as you said, I got involved with learning about Einstein and his relativities, especially the unified field theory. I read about them early on when I found out that I was born on Einstein's birthday, because the nuns at the Catholic school I was going to, the catechism, wanted us to find a saint born on our birthday. And back in 1965, there was no internet, so this was not a very easy task to do. You could go maybe to the library, but searching on a date for people born on that date, still a little bit difficult. So I just went to the calendar in the kitchen and saw that Einstein's name was on my birthday. So that's how I got introduced to Einstein, and I was fascinated by him the instant I started reading about him in the Encyclopedia Britannica. The other way really came about as an interest in many things, including UFOs and how they traveled, figuring that anybody who could figure out anti-gravity knows about the unified field theory. And then there were some messages given to me by psychics for almost 40 years of my life, ending up very recently after I finished this book, that basically said, this is very important work you're doing, you must continue, and putting it very mildly. That's why I'm writing a second book now, because during my period here that from the last time we talked, it's come to my attention that, yes, in the book I talk about the unified field theory and I show an equation and so forth, but I really needed to demonstrate the process mathematically for physicists. I have to play their game by their rules, and that's what I did. So I wrote a research paper. It took me 6 months to write. And in it, I unveil a small, simple set of equations that I use to predict the mass of the neutron. And it can also be used, of course, for the proton. And in so doing, I demonstrated the mechanical method that particles use to create a gravitational field. And that's the same field as the mass. mass is really a manifestation of a gravitational field. It's what particles are outputting as a result of the motion, the fundamental unbalanced charges, accelerated motion. So I did that mathematics, put that all together, put it in a paper, and demonstrated mathematically the mechanical model used for the unified field theory. So that's complete now and uploaded to ResearchGate. So that's basically a part of what I've discovered. And as you also already noted, that there's many other discoveries in the book concerning faster than light space travel, which on the way to discovering the unified field theory, I had to discover how particles moved. That was very important. And I discovered that and wrote that down in the book as well. So that's how we got where we are right now.
I'd like to go deeper, and maybe we could start with the cosmology theory, the cosmology of the theory of super relativity, and provide maybe your understanding or an explanation for it. You said that you have evidence that the universe is not expanding, it's actually collapsing.
That's correct. Yes, it all came about. Once you come up with a theory of gravity, then, it leads to thinking about how the universe was created. And it really came about as discovering the intelligent design, in particularly the neutron. The neutron plays an incredibly important role in how this universe is created. And that the odd, mysterious behavior of the neutron eventually led me into the theory of cosmology, because there's something the neutron does that's quite unexplainable. If you isolate it by itself, the neutron, within 15 minutes, if you just put it out in deep space, away from all other things or whatever, just one neutron by itself, within 15 minutes, it breaks down into a proton, an electron, and a neutrino. That is very important, because a proton and electron is hydrogen. And that hydrogen is the fuel of the stars. So now I understood or realized that that's no accident that particle behaves like that. Now, if the neutron is in an element like gold or silver or whatever, it's stable. It lasts billions of years as long as it's next to something, including other neutrons. And that led me into realizing that neutron stars are really a foundational, fundamental object. And one of the things that our astrophysicists don't quite have right is that stars, now we're getting into the cosmology, are really created as a result of the gathering of the hydrogen gas via what is known by many peoples, not Earth-like, as a sun source. The sun source being that there's a strong gravitational force being put out by neutron material, neutronium. And this neutronium had to come about as a result of the Big Bang. So stars were really being formed because these neutron spheres that came out of the Big Bang spread across the universe along with neutronium gas or neutron gas. And within 15 minutes after the Big Bang, because according to the theory of super relativity, the cosmic egg, the huge black hole that let loose in the beginning, was made of solid neutronium, very incredibly dense neutronium or neutron material. And when it reached its critical mass, it exploded and put out not only the neutron gas, which within 15 minutes turns into hydrogen. And now we're ready. The universe is ready to start building stars 15 minutes after it's born. Because all of that neutron gas is going to turn into protons and electrons, which form hydrogen. So now you have the basic material all stored away, neatly packed into something before the Big Bang. and now it's let loose. But also that what's let loose at that time is neutronium spheres. All of that neutronium material didn't vaporize into, from the explosion. They went out in various sizes of neutronium spheres. And those are the objects that gathered the hydrogen gas after the initial Big Bang and formed stars and galaxies. And you'll notice that almost in the center of every galaxy is a black hole. Those black holes are made of neutronium, and they are extremely stable. So this is the system that drives the universe, the basic cosmology that explains the birth of the universe and its eventual death. Because now what I've discovered is the universe is collapsing. It's not expanding, and that's confirmed by the fact that my research has indicated from the research of Barry Setterfield that the speed of light is slowing, which is a key factor in discovering that if the universe were expanding, the speed of light would be speeding up. And that's not what they found when they researched this over the last 250 to 300 years. Barry Setterfield discovered that the speed of light is gradually slowing down. Why? Well, what I also was able to determine was that the speed of light is slowing down because we're heading toward a gravitational source. And in fact, astrophysicists have discovered that our solar system, our galaxy, the Milky Way, along with Andromeda and all the other nearby galaxies, are being pulled towards something huge. It's called the Great Attractor. This is well known, not highly publicized, but well known. And we're all going in that direction, and we're not, going away from each other. We're being gathered. And in about 4.5 billion years or so, we're going to arrive at the Great Attractor. And by that time, the speed of light will be almost to zero, because it's already a known scientific fact that light speed slows down when it enters a gravitational field. The stronger the gravitational field, the slower light moves. That's why light is slowing down. We are proceeding toward the Great Attractor, which is an immense black hole that is thousands of light years across. And we're heading toward there at 1.3 million miles an hour and accelerating. Fortunately, it's going to take a long time to get there. So we have plenty of time to evade this, imminent, not so imminent disaster. So that's the theory, the really basic nutshell theory of the cosmology. It's a cyclic universe, which whenever it gathers all of the matter back together again, the gigantic cosmic egg, the neutronium sphere of it's now millions of light years across, becomes so dense and so compact that the inner core superheats. And this superheat, which is at many trillions of degrees, causes the next Big Bang, and the whole process starts over again. And then everything spreads out, stars forms, more black holes start to combine, create bigger black holes. Pretty soon you have Titan-sized ones like the Great Attractor, which, by the way, is being attracted to an even bigger black hole. So the gathering is already well underway. And what we have mistakenly thought is that the universe was expanding because we looked out into deep space and we saw these galaxies were accelerating away from us. and they mistakenly, the theory put forth by Hubble and others at that time, was that meant the universe was expanding because they put us as the center of the universe, which is ridiculous. The whole theory is founded on a concept that makes no sense. We cannot be the center of the universe. And so what was causing these galaxies that were further and further away from us to accelerate? They're all falling into larger black holes that are beyond where we're measuring. And so the falling into these black holes is a acceleration factor. Just like here on Earth, if you drop a ball from an airplane, it's going to accelerate because of gravity. That's what's causing these things to accelerate in deep, deep space. They're actually moving towards something. So that is explained, and it's not by space expanding, it's because they're being contracted or pulled into these other black holes all over the universe. And those black holes will gather all the material and eventually merge until they all merge into one again. So that's the basic cosmology theory of superrelativity.
This would probably change what we think and what we know about black holes. Could you give us more about what you, based on your research, what you found out about what a black hole really is?
Yeah, well, it's common knowledge that, when you have these supernovas, after the explosion is over, what is left? In every case, it's a black hole. Now, that's being credited they're saying that black hole was created by the explosion. It doesn't really make sense, does it? Very rarely do you ever find anything, if ever, when you blow it up, it comes together. And what I believe is happening is that the pressure from the star, when it's in its advanced stages, you get more and more heat energy and from the fusion process of the heavier elements. When it gets to that point, the atmosphere around the black hole that has gathered all the hydrogen becomes so unstable that it pushes away from the black hole, blows out, and then the black hole or the neutron star, it could be either one, is revealed again. So it was there already. It's what created the star. So I'm saying, hey, well, if stars all have neutronium, that means the sun has a solid neutronium core. So then I went and I looked at measurements that were, which is called the Techaline measurement from NASA. It's a chart you can look at, and it's got lines going together and they form one line. So what it's doing is measuring the rotation of the sun at the very outward part, and it's a gas. The gases are rotating. And as you get further and further in, the gases start to rotate as if they were a solid. They becomes one. At one point, it all drops off, and it becomes like a straight single line. And that's indicating that whatever in the middle is rotating solid, and it's rotating faster than the stuff on the outside, the atmosphere on the outside. So there's indication that there is something solid there, proven by NASA, but they just don't accept that there is something solid there, and that's what caused the sun in the first place. They're not acknowledging their own evidence. That's a solid evidence that there's something hard, very dense inside of the sun, and that's basic evidence. The cosmologically speaking, there is a great deal of evidence that supports the idea that stars have neutronium cores. So this is why I keep saying the neutron is like the most incredibly important object in the universe, because it's a neutrally charged object, which means you can really pack it together very tightly. And the tighter you pack it, the stronger the gravitational field becomes. So what is a black hole? It's just a super dense neutronium or neutron star. And when you get to maybe 8 or 9 solar masses, that gravitational field becomes so strong that light cannot escape it anymore. But a neutron star and a black hole are the exact same thing. They're just, black holes are just bigger sizes, much stronger gravitational field than ordinary neutron star.
I want to go back for a second to the Great Attractor that you were talking about, this supermassive black hole. Theoretically, what happens if we were to reach this Great Attractor? Like if planet Earth were to actually be within the proximity to this?
Well, right now, we're on the far side of the Milky Way galaxy. So if you go out at night and you look into space and you see the Milky Way, if you're fortunate enough to live away from the cities and there's no light pollution, you could see the Milky Way. And if you were to look straight through the middle of it to the other side, that's the direction of where the great attractor is. That's where we're heading toward right now. And in approximately 250 million years, we'll be on the close side toward as we move toward the black hole. And that's a considerable amount of time. We'll be, a lot closer than we are right now. But as we get over, depending on which side of the galaxy we're on, when we encounter that the great attractor, what we'll see in the sky, the speed of light will continue to slow down. Unfortunately, we won't know it because the way we measure the speed of light is now improper. It was discovered back in, the late 1920s, early 1930s, that every time we measured the speed of light, we got a slower number over the past 300 years since the first time we measured it. And it was really aggravating the scientists because we were trying to pick the number. Einstein said the speed of light is constant, but gee, every time we measure it, sometimes even with the same equipment, a few years later, we get a lower number. And finally, they just declared, Raymond Burge declared, he was the chairman of physics department at the University of California. He says, okay, you know what? I'm picking a number. This is the number, and that's it. We're not going to accept any other number. And that's what became the speed of light. And from that point on, we started to change the way we measured the speed of light. They assumed that if you got any number different from this number, your equipment needed to be adjusted. So they started moving the length of the mirror separation, so they got that number. And so now we have no more slowing of the speed of light because we're adjusting the equipment to get that number. So we're not going to know it. The only indication we're going to get is that in order to get this number to be right all the time, the length of the meter has to shrink over time. And so millions and millions of years from now, the meter length will be half of what it is now. So somebody might notice that at some point and say, hey, meter's a lot shorter now here, 500 million years later than when we first created it in the golden platinum thing in France. The original one doesn't make sense. Wonder why it's half the distance of what it is or what it was back then. So that's it's going to happen. We're going to detect the speed of light is slowing eventually. When we look at the meter and say it's half as long or less, there will be a big black spot in the sky. When we look out at night, there's just going to be this dark region, and it's going to grow. And our clocks will begin to slow down because that's another effect of being in a strong gravitational field. And eventually, at the very last days, it's going to be horrible because the night sky will be completely black. There'll be hellacious problems with tides and gravitational anomalies that'll make people extremely nervous. And then we'll pass across the event horizon and it'll be over. But, we're talking about 4.5 or more billion years from now. It's nothing to worry about, nothing to panic about.
Right.
It's not going to happen anytime soon. The trick is we have to be off this planet by the time that comes. We have to move our race. We cannot stay on Earth forever. One way or the other, this planet is no longer going to be a place that you can live on. So we have to get faster than light technology going so we can dodge the punch in the face when it comes from some catastrophic event. So
well, that's a perfect segue into talking about that. Based on your research and your work with, the theory of relativity and the other things that you're looking into, what do you think is our best route for space travel? Would it be through wormholes or faster than light technology?
Well, that's assuming the wormhole theory is a speculation, a theory that somehow magically you can go into a black hole and it's going to be like a enfolded space where you can jump from one region to another through. But if you go through a black hole unprotected, that'll be the last thing you do. You won't go to a wormhole anywhere. You'll end up on the surface of the neutronium core of this black hole, and your atoms will be crushed to the point where they'll be transferred into neutrons, and that'll be the end of you and your spaceship. So wormhole travel, forget it. That's just not going to work. That's a very highly speculative, unproven theory. The way to travel beyond the speed of light, the key was revealed to us by James Clerk Maxwell back two or three centuries back, who discovered an equation for the speed of light. C equals 1 over the square root of permittivity times permeability. These are two properties of space. So if you drop these, if you can manipulate these two properties of space, if you make them go lower, then you can go beyond the speed of light. And if you do the math and you calculate it, as those numbers, permittivity and permeability, go smaller, the speed of light goes up. So that's the key to making a spaceship that can break the light speed barrier. You have to buy a space with a force field, and that force field would be the magnetic field. It's the most sensible approach to this situation, because a magnetic field is a field that can be used to stretch space apart, whereas gravity is a contraction of space. We don't want that if we're building a starship. We don't want to create a gravitational field to create a wormhole, which is going to kill us anyway. We want to stretch space apart. Just like a bubble rises from the bottom of the ocean because of a pressure difference, you want to create a bubble in space. And space, that means, has to be a real physical object with properties like permittivity and permeability and density. So we use the magnetic field to drop permittivity and permeability, and at the same time stretch space, lowering its density around the spaceship. That's the anti-gravity field. And when you configure it in such a way as that you have one end that's a very strong magnetic field, and then the next end you go back and stronger until the back of the ship has the strongest magnetic field, you've created a pressure gradient, and that will cause motion, as well as it's all a pushing against the background of space, so that you get propulsion and you get anti-gravity, you cancel inertia, and you drop permittivity and permeability, everything you need. It all works out perfectly to give you everything you need to break the light speed barrier by any number you desire. So if you want to go 10,000 times the speed of light, that's no problem. If you want to go 100,000 times the speed of light, still no problem. 1 million, 1 billion. What you don't want to do, what we don't ever want to do, is drop permittivity and permeability to 0. Because if that happens, then you're going to go infinitely fast. And you're going to get lost, because you're not going to be able to track in an instant at that speed where you're at. When you slow down again, you're going to be out of the galaxy, more than likely out of the universe, in between universes, God only knows where. So this starship has to be able to monitor its adjusting of permittivity and permeability in the space around the spaceship. And it's very easily possible to go to Proxima Centauri, which is 4.5 light years away, in a matter of minutes. And this is what is necessary in order for us to have starship travel, to be able to go to other stars. You can't take years. Even going at the speed of light is way too slow. You have to break the light speed barrier by a large number to get to where you're going in a hurry, because traveling at this speed is very dangerous. You don't want to be doing it for very long. You want to do it, get there, be done, back to a safe level of motion at another star, explore it, examine it, and see if it's a place we can live. So that's basically a very simple solution to the problem. All problems that happen with accelerating toward the speed of light are fixed by using the slip wave, which is in my book, which I talk about, which is the method of biasing space so that you can create a pressure field that propels you through space.
Now, say you had, unlimited resources and engineers and scientists working with you. How many years do you think that it could be developed if, we're actually taken seriously by our scientific community?
I would say, well, first of all, I would say we already have this technology. Mm-hmm. I believe the United States government already has it.
Right.
They reverse engineered crafts that use this. And they no doubt saw that the crafts inside of the crafts under the metamaterial covering that they're made of, they've discovered coils of superconducting wire. And so one of the things we have to have is superconducting wire. I'm going to assume at this point, we've already discovered that and it's been classified. So assuming that we already have the superconducting material, and I mean room temperature superconducting, you cannot build this with having to freeze the coils down to, the temperature of liquid nitrogen or something. That's unsafe, because if it collapses en route, it's a fatal. You cannot come out of the warp by shutting the magnetic field down. You will die instantly if that happens. Scotty won't be able to adjust the ship. It's over instantly if you lose the magnetic field while in flight beyond the speed of light. You have to maintain it all the time. So it's very unsafe to travel this way. So you have to have very, very reliable equipment and redundancies and so forth. So how long would it take? With the help of the military, 2 years. Without the help of the military, if they want to keep us in the dark, we have to, somehow find somebody that's made the superconducting coils for the magnets that will go in the hull of the ship. And then we have to have a power source. And I'm not talking, somebody cranking on a bike or whatever, turning a dynamo or whatever. We need, I would estimate, many mega volts, or I should say megawatts of power to drive these coils. That uses a lot of electricity to make these magnets. Not out of our range. I think we need a power supply the size of a basketball that can generate several megawatts of power. As far as I know, that doesn't exist, but I'm sure that the government either reverse engineered the alien spacecrafts or have been working with them and have this technology given to us already. So, if we had the government's help, 2 years or less. Without it, maybe 5 years, because we know what we have to do. We know we have to have a powerful source, extremely powerful generator, and we need the superconducting coils. These are the two key ingredients. How I know this? Because I've seen the Air Force for the last 40 years invested in everybody who's doing superconducting and magnetic work. The Air Force seems to be right there at all of these labs and institutions as a founding member. And they're also looking for anybody who was, or were looking for anybody who was generating power, free power, and they were interested in anybody that was doing that kind of work. And so I'm pretty darn sure those two things need to be handled, taken care of. Then we need to start doing the experiments to see how much magnetism can be used to control gravity. And we have to have a way of detecting the drop in permittivity and permeability. These things have to be known experimentally and with equations so that we can predictably create a warp field that gets us through space safely and without any inertial leakage. If there's any inertia squirting through the craft, it'll kill anything it comes across at beyond the speed of light, crushing the bones and turning your flesh to mush. The field must be complete, encompassing the whole ship. Fortunately, the anti-gravity field cannot be shielded, as gravity cannot be shielded. So the magnetic field has to be shielded, so we have to put a covering around the inner part with using magnetic shielding material. And there's two types: diamagnetic, the kinds that reflects, and then ferrous magnetic, the kinds that absorb the lines. So we can protect the inhabitants of the spacecraft from the strong magnetic field. But the anti-gravity field just sifts right through that whole thing, and you're basically floating inside of the ship as you're moving, many times the speed of light or whatever. All it feels like to you is you're just in a anti-gravity field in deep space, like you're floating around. You will not be aware of the immense speed you're moving at. So I'm going to say 5 years without, some authority figure helping in some way, saying, yes, anti-gravity is real, and this is how you do it. If not, we're going to have to go through the experiments and so forth to determine, which the best way, which the best design, and so forth.
Yeah, I don't think I would be doing any space traveling for a while until they get all the bugs out. It seems to be pretty dangerous unless you know exactly precisely what's going on there. Now I want to. Yeah, so I would give it a while for myself. I don't even know if I'd be doing any space traveling at all. We'll see. I want to go back to a minute for what you were saying about the sun source and how all planets are formed from this sun source. And you said that aliens and possibly angels, they know about this. Now, how do you know that they know about this?
Yes. In my next book, I'm going to detail all of that because it's quite a bit, gathering the information. One of the things I was very open to doing that regular scientists are not is using information that comes from the spiritual realm or the paranormal, or whatever you want to call it, by accepting that's real, and that not everybody's making up stories just for profit or whatever, that there is an afterlife. And there is a God. So super relativity theory is an intelligent design theory, and I do not apologize for that because it's just the way it is. And the sooner we become aware of that, the sooner we will advance, the better and faster we will advance by acknowledging that there is a creator. So that's what I basically did. So how did I get some of my information? I said, okay, I looked for it via near-death experiencers or talking with psychic mediums and asking specific questions about the creation. If you want to know how something works, you should go to the creator of that something and ask them. That's what I did through my entire troubleshooting career. When something broke down and everybody was wondering what's going on, the first thing I would do is go to the designer of that electronic circuit board or the developer of the software, and I would ask them, how does this system work? And they explain it, and it makes sense, and then you know what's going on. So I just employed that same troubleshooting theory here. Instead of burying my head into the sand and saying, there is no God, there is no creator, let's just figure out this random thing, I just went to the source on some instances and was able to determine things like what the inside of the atom looks like, or inside of the neutron and the proton. These are the three quarks as they move inside of the neutron and the proton. This is how they generate the gravitational field, by moving in an accelerated manner. So that's the basic way in some instances that I got extra information, detailed information that fit into the theory and made sense. These things, in my theory, it's nothing but hardballs right down the middle of the plate. I don't pitch anything that doesn't make sense. If you understand the theory clearly, as I explain it, you will say, hey, that really makes sense. It has to be that way.
I always say if we would bring some of the nuts and bolts research to some of this consciousness, spiritual, some of these spiritual researchers, I think we could get a lot further in figuring out the nature of reality, what's going on, hidden technologies, what the government is hiding from us, all these things that we could really benefit the human race. We could find out directly from the source and creators of these things if we were open-minded enough for it, you know?
Yeah, it's our society. We haven't really evolved enough yet to handle the idea of aliens, ETs, and all that stuff. I think there's a lot of people that think there would be a big worldwide panic if United States government. I've even heard that Trump wanted to reveal it, but was stopped by the intergalactic federation. Says your people are not ready for this. If you do this, you will cause a worldwide panic. This has to be done slowly over time. You have to evolve more. Your race has to evolve more. And so there's parts of it who's gotten this information, maybe the military parts, who are still acting in ways that are like there's a war going on, and they got to keep it secret, because this information is strategic, gives us a strategic military advantage. So they want to keep it hush hush, and they do. And so we're our own worst enemy. We haven't evolved because of fear, and basically that's it. When we evolve more and we are just open, hey, of course there are aliens in other worlds. It has to be. If you look at the numbers mathematically, the stars that are out there are more than all the grains of sand on the earth. There's a lot of stars. You're going to tell me we're the only planet with life on it? That's not going to turn out. Once we get starships and we start going to the nearest stars, we're going to see, hey, there's planet with life here, planet with life. It's all over the place. I mean, it's like incomprehensible. There's so much life out there. But as long as we remain in the darkness with our heads stuck in the sand here, it's going to be slow going.
What do you think was behind this recent kind of uptick in disclosure talk through the media and our government and these documents that were released? I mean, it seems to come and go and in little spurts, and they seem to throw out little hints here and there and slow strip this disclosure thing. But recently there seemed a bigger interest than usual. What do you think was going on?
Well, what little disclosure there was fairly predictable. They said, yeah, there's something out there.
Yeah.
Well, we don't know what it is. We're just like you. We don't know what it is. Baloney. They know what it is. And in some cases, it's probably our own ships that they're just running by our Air Force and seeing how they react and seeing, well, how is the best defense systems in the world going to react to something that can literally fly circles around them? And so, maybe some of these tic tac things, maybe that's our own. Maybe it's the aliens. I don't know. But all they've basically said is, we're going to stop lying to you and saying that there's nothing out there, or it's swamp gas, or it's Venus or whatever, because that's not flying anymore. Nobody's believing that. So we'll just say, yeah, there's something out there, but we don't know what it is. And that's the new lie, I guess. But what's interesting is I just read a little article that was sent to me by someone. And in this article, the retired defense minister of Israel came out and says, yes, the U.S. is in contact with aliens, and so are we. There's an intergalactic federation that we're aware of. I don't know if we belong to it yet or not. And that's part of the reason why the Space Force was created. And in fact, Trump wanted to disclose this, but was stopped by the Intergalactic Federation. So that's how I came across that little piece of information. A bona fide person who was in the highest part of the defense of Israel admits that the U.S. has been contacted by aliens and is working with them at this time.
Yeah, that's really interesting. I remember when that came out. It also makes me wonder how much of this is just misinformation to confuse the public about what's really going on out there, because it's quite fantastical what the Israeli Space Force gentleman said, and a lot of the other things surrounding it. But then again, we found out so much of what the government and even our own history has been a lie recently. It doesn't even surprise me anymore, and it's highly possible,
Well, let me tell you this. I can't tell you the name of the person, but I was contacting. I do a lot of shows, and every once in a while, somebody sees one of these shows who was a person who saw something. These two people were afraid to come forward. They've never come forward. They've never written a book, and I don't know. Maybe someday they will. But what these two persons saw in the desert in the 1970s was a UFO. They saw it very close up because this thing landed right in their vicinity. They were able to walk up to it. And what did they see written on the side of the craft? United States Air Force, experimental. So now I have proof, positive evidence that we have these things, that we built these things. And we're flying, and that's back in the 70s. So you could bet they're a lot better than that version, which made a lot of clanking noises and spinning things going on in there.
Yeah.
I bet you they look and work a lot better now because they were just testing these things out.
Wow.
And they've had these probably since, the 50s at least.
Yeah. That is very interesting. I want to talk about what neutron decay is and how it kind of could point to intelligent design a bit. This is part of your research, right?
Yeah. Well, when I just general studying, I came across this whole thing that it's a mystery to physicists why the neutron is unstable in this particular circumstance. Its behavior is circumstance dependent. If you isolate it, it will decay, as I said, into a proton and an electron, which is very handy because that's hydrogen. And I says, wait a minute. What if I assume that's not a random accident? What if I assumed that it was actually designed to do that? Then I would say, let's go explore the idea that at the beginning, because we know we need hydrogen to build stars and a universe. That's like critical, and you need a lot of it. And so whatever happens in the Big Bang, it has to bring about the availability of a lot of hydrogen. And so using my idea that I've observed that neutron stars come about when stars explode, and it explains how stars are created in the first place, because the old theory of stars just happen because, well, there's a lot of gas, and somehow the hydrogen gas in space where there's no pressure to push it together, it just gathers. And there's no way that can happen because protons are positively charged, and the repulsive force of the hydrogen is orders of magnitude greater than the gravitational pull of those pieces of little bits of hydrogen. So that gas will never accumulate. And they know that. And so they get all kind of fuzzy when you press them. Wait a minute, the gas just comes together? There must be a gravitational source. So that's when I assume that I say, hey, it's got to be the neutron stars. The neutronium, when they blow off in these supernovas, those things were already there. That's what created the star in the first place. So then I thought, well, how did the planets form? Probably the same thing, only they are composed, their cores are much smaller neutronium cores. So they gather all the hydrogen gas from themselves, and they burn like these brown stars. They're very not brightly lit, but what's going on is that the hydrogen that was formed gathered around, like, let's say, the Earth neutronium core started fusing, became a helium, then carbon, then silicon. And sure enough, Mother Earth has every element in the chart. How did that happen? They just fall out of the sky? As the current theory says, they were made right here in the core. And if you see in volcanoes and other places where metals are deposited, there's groupings of crystals and gold and stuff. There's a manufacturing plant, a fusion plant in the center of the Earth. And I said, okay, fine. I need more evidence. If there's fusion going on in the center of the Earth, creating all the elements that we have here on Earth, if there's a neutronium core, there's fusion going on because that gravity around that neutronium core is immense, so strong it crushes the elements together, the hydrogen and the other elements to form more elements, the heavier ones. So there must be a fusion process. That means that if we point a neutrino detector at the center of the Earth, we're going to see that neutrinos are coming from the center of the Earth. And sure enough, a scientist in Japan did that. I wrote him and congratulating him on detecting neutrons coming from the center of the Earth. So that means there's a radioactive process going on there. Either there's fission or fusion. So we've got a confirmation that more than likely it's fusion, because if it were fission, the material, the lava coming up would be highly radioactive, and it's not. So odds are there's a fusion process being created in the center of the Earth by a neutronium core, which is how the Earth, the Saturn, Jupiter, all the other planets, all around all other stars were created using the same process, which is neutrons. And it just smacks of intelligent design, because this system works so well. And it's designed for one thing only: create a situation, a stage that life can evolve. So to me, that can't be accidental. It's so perfect in its design and works so well. It has to be from an intelligent design.
Yeah, lately I have been extremely disappointed and disgusted in the direction that mainstream science is going, and it keeps getting worse all the time. I doubt that they would ever even come around to any of this information, just because they want to keep control. And if this information got out, all the control would be lost, because we would have this power and information that could change the planet for the better, and we wouldn't need their crappy technologies and all these things that keep us down as a species. So it's a threat to them, I believe, that if this information would ever be accepted by anyone in the mainstream. What do you think?
It's a hard battle. I've given it a lot of thought, because they're really dedicated to the idea that quantum mechanics is correct. Einstein was the first one really to take on quantum mechanics. Even though he helped create it, he could see that it was getting out of hand, that you can't base a whole theory of physics on probabilities, because probabilities doesn't tell you how things work. Probabilities happen because of deterministic things that go on. Granted, they're very complex at the very, microscopic level, and becomes difficult to calculate using, differential equations and so forth. But nonetheless, that's the way it really works. And the problem is you get very strange theories that do not make sense with quantum mechanics. And there's loads of them that do not make any sense at all. And some physicists are very unhappy about it. Others say, hey, if you're going to model reality, you better use quantum mechanics. That's Richard Feynman's quote. But at the same time, he also knew there's something wrong. Like in one case, he says, the extreme weakness of quantum gravitational effects now poses some philosophical problems. That's what you and I are talking about right now. Maybe nature is trying to tell us something new here. Maybe we should not try to quantize gravity. That's from Richard Feynman. And there's more. What if quantum theory is wrong? This is the soft underbelly of the whole project of quantum gravity. If quantum theory is wrong, then trying to combine it with gravity will have been a huge waste of time. That's Lee Smolin. There are people out there, physicists, they're really having a hard time with quantum mechanics, but they're not willing at this point to jump away from it, because there's been so many successes. Look how we can predict this and that, which is a lot of the stuff is trivial in my opinion. Every time you use a particle collider to smack particles together and get something new that doesn't last but maybe a billionth of a second, who cares? That's not relevant to our lives and to the way things work here at home and in our bodies even. we're not smacking particles together in our bodies to get all these weird things that they get in colliders. Most of the great work has already been done with the discovery of the fundamental particles. And that's what we should be working with and dealing with, and not trying to find a new particle that has very little value add to the world. We're not really progressing, and string theory is even worse yet. We're wasting our very best minds on a theory that's not even testable. We'll never know if we have it right, and it's so complex, it can't possibly be right. And it's tragedy because our best minds are being squandered working on theories that are hopeless.
That's very interesting. Yeah, that is definitely the direction that mainstream science is headed, is looking into, this quantum field. But what you're saying, I mean, it makes so much sense. I want to end on talking about what you are calling the stellar converter, and something you've been working on. Could you tell us a little bit about what that is and possibly what it could do for us in the future?
Well, when I was going through and making the discoveries about the great attractor, and we're being pulled toward this, ooh, this is not a good ending for us. I wonder if there's any way to fix this problem. So I said, well, in order to fix this problem, we have to eliminate the gravitational source that's sucking us in and going to kill us someday. So I thought, well, how could we do that? You would have to make the neutronium material unravel, come apart. And the only thing I know to do that is if you drop something in toward the surface of a neutronium core, and you have to drop it at the poles because it's spinning rapidly. If you do it on the outside, it's going to be a catastrophic problem there. So you drop these rings of magnetic coils. So it's a slipway bias field, an incredibly intense magnetic field. And you have these rings and you drop them down at the poles until the magnetic field makes contact with the surface of the neutronium core, at which point the gravitational field will be canceled. What's holding the neutrons together will be canceled, and the particles will then just boil off the surface of the neutronium core up through the ring, the center of the ring, and be shot out into space at the speed of light, or maybe possibly slightly beyond it, until it breaks away from the magnetic field. And sure enough, there's things in deep space called quasars, and they know they're black holes, but there's this immense amount of material coming out of the poles of these things in deep, deep space. I mean, way out there. And we were able to tell that there's an incredibly strong magnetic field at the poles. How did that get there? And how do they know that? Because the light coming off is polarized, and that only happens when the light's going through a magnetic field. So it is detectable, and they know and they measure the speed of these particle jets coming off of these things. They're immensely bright, bright as a whole galaxy, and they're shooting away from these quasars, which are black holes. And there's two theories on how that's happening. There's a lot of debris around the middle of it, ionized debris, and it's forming a supermagnet, and it's going down through the poles and causing the burst of energy and matter out of the black hole. Or somebody has made a stellar converter, and they're harvesting hydrogen and using it to build new stars. That's why I call it the stellar converter, because once you pull the neutrons away from each other and then put them into space free floating, within 15 minutes, they turn into hydrogen. And if you can then guide that hydrogen toward a neutronium core, you can build a new star. You can build your own star if you wanted to. So that's what the stellar converter technology is about, basically undoing black holes and not doing it too fast. There's many versions I put in the book. One where you make it explode, which is highly dangerous, and I don't recommend. But if you do the draining, the siphoning method, it may take a long time. But if we were to start now, because with a starship like I'm describing, we can get to that black hole in a matter of hours. And if we could start constructing, and I'm sure, if this is something that they're going to do, advanced species are going to do, you're going to do it as a group, as it takes a lot of resources to build this thing. And they would, be there assembling already, trying to eliminate the black hole that's going to destroy all the galaxies that are falling toward it. It's a lot of work. It's just an idea I came up, a solution for that particular problem. And it may not be something that we should do, because maybe really we need to use the natural method of allow the universe to collapse back altogether. It takes all the matter and energy. Once it's all back into the cosmic egg, it blows apart. Our universe is eternal. It's cycling. And then it starts all over again. And then we can, we'll have a new planet that we can reincarnate down to and continue this epic adventure till the end of time, which will never really end for people on the other side. That's an eternal world, a spirit realm. But here, there's always a beginning and an ending.
Man, that's fascinating.
The good news is it cycles.
Yes, everything seems cyclical, definitely. And I know you said you're working on a new book. I'd love to have you back on after that, and we can talk a little bit more about that one.
Yeah, it's a meaningful book now that this book is out, and the math I've done, and I'm very convinced I have the unified field theory, and now it's just a matter of convincing mainstream physics, which I hope I can get on some science shows and talk to them about these ideas, these concepts, and see what they have to say.
Yeah, that'd be great.
If my theory becomes confirmed, the second book, which is a prequel, basically telling the whole story of how all this came about, is going to be, everybody's going to want to know, how did he do that exactly? Because he's not really a physicist, and he's a metaphysician, a self-proclaimed one, a philosopher. How did he just figure all this stuff out? And I think possibly one of the main reasons is, obviously I'm getting help from the other side through some sort of infusion process. What you would call channeling today, or something of that nature, intuition, whatever. Right. And the fact of the matter is, the unified field theory problem was never really that hard. We've made it hard. And so it was a solution that was capable, graspable, achievable by somebody that didn't have to really be a super genius.
Yeah, that's fascinating, and we do that all the time with our history and inventions and science, and we make it more difficult than it has to be. And Mark, I want to thank you again for coming on. For people that want to find out more about you and your work, what's your website, social media, all that good stuff?
It's www.super-relativity.com. super-relativity.com. That's where you can buy my book. I can send you a signed copy, or you can go to Amazon and get the book or the Kindle version as well there. So, and there's more information about me and my theories and ideas on my blog. And there's also some old shows you can watch that I was on. And so there's lots of stuff to find out there about concerning the master of reality and the theory of super relativity.
Awesome. Well, Mark, thank you so much. And I'll be in touch. We'll talk again after your book comes out.
Okay, will do.
Awesome. Well, until next time, everyone, have an excellent evening, and we'll talk again tomorrow.